Hey guys, in this video I'll be explaining imaginary numbers, and I'll be going through the basics of imaginary numbers. So imaginary numbers, the purpose of them is to simplify negative square roots. So if we were to look at negative square roots in terms of real numbers, there would actually be no solution because there's no way to actually simplify a square root without it being positive in terms of real numbers. So if we were to take square root of -1, that's neither 1 times 1 or -1 times -1. So if we were to look at it real numbers, like I said before, we would just think of this as no solution. It's actually should be in the middle. But the purpose of imaginary numbers is to solve negative square roots. Therefore, the square root of -1 is equivalent to I, meaning that if we were to square that, -1 times -1, because that's squared, you get -1, meaning that I squared, because this is I and this is I, so I squared is also equal to -1. So using this, by remembering this, you can remember the basic I exponents, meaning the basic exponents of imaginary numbers. And I would like to first start off with I to the 0 power up to I to the 8th power. So I to the 0, I to the 1, I to the 2, I to the 3, I to the 4, I to the 5, I to the 6, I to the 7th, I to the 8th. As we know, any exponent to the 0 power is 1. That's easy. We know this is just I. We know this is -1 like there. We know this is just, -1 times I. So we know this is -I. We know I to the 4th power is just -1 times -1. That's in the multiplication. So we get 1. We know I to the 5th power. What you can do is you can take the previous term. So since we know this is 1, we know this is 1 times I, and we just get I. We know I to the 6th power is just I times I. So you get -1. For the 7th power, I to the 7th power, we know that I to the 7th power is -I, because -1 times I is that. And -I times I is just -I times I is just 1. And if you notice, there's a common similarity here. So the same answer repeats every four exponents, meaning I to the 0 power is here, I to the 4th. I to the 1st power is the same as I to the 5th. I to the 2nd power is the same as I to the 6th. And I to the 3rd power is the same as I to the 7th. And I to the 4th power is the same as I to the 8th. So using this tool, you can solve for the exponents of larger imaginary numbers. Meaning, if you were to take a value like, I'm just making this off the top of my head, I to the 289th power. So now with the I to the 289th power, this is too big of an exponent to solve by hand, so we just do. So what we do is we just take it and divide it by 4 because of the way in which they skip by 4. You get 7, and since this is a 9, you get 2. So your remainder ends up being 1. This means that this is the same thing as I to the 1th power, meaning the simple answer is I. So using this method, you can also simplify larger exponents of imaginary numbers. So one more way in which you can use imaginary numbers is when simplifying a large negative exponent. I wouldn't necessarily say this is hard, but sometimes people get confused with it. So all you have to do is you have to isolate the I. So you know this is -1 times square root of 64. And since this is I, the I is automatically simplified. And then you just do square root. So you know that 64 is 4 2/3. So it ends up being 4 root 4. And if you multiply I, you get 4i to the 4th power. So that's it for this video. Thanks for watching. Please give the video a like and subscribe to the channel. And I hope to see you guys next time. Thanks for watching.